Hello, Internet. Um, Another GPU from that exact same customer with the EVGA 3090 that we managed to fix in our last video. This one's very interesting. It does not post. The HDMI port has completely no reaction to the monitor. The monitor does not go black at all when the GPU is powered. But I wonder, and the display port does react. It goes black, but nothing happens. I'm not getting any. There's nothing on the screen basically. I'm not getting any funny errors, funny beeps or whatnot. So plug it in, power it on, like no reaction whatsoever. But if we plug in the display port, the monitor goes black. That's because it's reacting to something, but still nothing on the screen. So turn this thing off, and let's go and I'm gonna go into Windows, and I'm gonna go and see if I think there's no problem with the core or memory here, or even the BIOS. Because if there was a problem with the BIOS, the HDMI would, while it would not display, at the very least, it would react. VGA card is not supported by the UEFI driver. What does that even mean? Have been changed for better compatibility. Okay, never mind. Have to. So an older card, UEFI, CSM, who knows? Who cares? Yeah, so if the problem was with the BIOS, then the HDMI port would still react and the monitor would go blank. But in this case, it doesn't. So gonna wait for the device manager to see. It's already detected. We're just gonna wait for this thing to pick up the drivers and see if it's actually working. My guess is that it works perfectly fine, but we have a problem with the display circuit. I'm guessing we're missing the DP enable or something like that. So let's wait and see what it does. Okay, so the display device manager says that we got an NVIDIA 3070. If we open the GPU Z, if I see all the data, then that means we are good. Let's see, 70, and bam, I see all the data. Perfect. So my guess is the GPU is probably working fine. We can even run what is this, Heaven, just to see if there's any like artifacts or whatnot, which I highly doubt. See, it looks perfectly fine. All right, so let's turn this thing off, shut down, figure out what's going on. Okay, so the prime suspect would be the display ports, the HDMI ports themselves. Like, why does this not react while these two do react? I don't know. I'm guessing physical damage somewhere, but the port looks okay. I don't see anything inside the DP ports either, so it looks good. Then maybe something on the back of the board near the ports, usually around the mounting holes. Somebody would take the GPU apart to apply paste and whatnot, and then they knock something off. Very common. This is one of the reasons why I support the idea of user opening their device, voiding the warranty, because you believe it or not, a lot of times that's how they break. They open it to change the paste, put it back together, it's dead. It's that simple. And then some of the young angry people, they say, you now owe me a free GPU. It's supposed to be covered by a warranty. Just because I opened it doesn't mean I broke it. Yes, sir, it does. You opened it, you broke it. It's that simple. Statistically speaking, at least. So I don't see anything here. We're looking for the mounting holes, damage associated with the mounting holes anywhere near. Looks like we got one BIOS, no BIOS switch. So let's look around in here. Basically any hole that we're looking for could have damage nearby. It could be anywhere on the board. Just because we're having a problem with the display port does not mean that the damage is not 300 miles away. So I don't see anything here. That looks sketchy. But it looks factory, so who cares? All right, let's flip the board over. Start looking for problems at the front. So basically, when the HDMI port has when the monitor does not react to the HDMI port, that means that the 5-volt is missing from the HDMI port itself. The card is not generating it for whatever, or not sending it through for whatever reason. It's either a knocked off component, or the display circuit is not enabled, or something else. So continue on looking. It's not going to be any of the driver MOSFETs, obviously. I already checked those. It's not going to be data line issues either. It's not going to be BIOS, because the BIOS and the data lines all seem to be working. There's something somewhere, something very small. Maybe a scratch, maybe a cut trace that I cannot see easy enough. So we're paying attention to the mounting holes and the components that are nearby. Oh, look at that. See? Check it out. We have rust. Whoa. And this guy here, I bet this is the one that's responsible for the display enabling stuff. Okay, cool. So just corrosion, and oh, look at that. It looks like we got a cap broken off. Is this filtering capacitor? Can we ignore that? Let's bring in the meter, main and meter. There's a meter right there. Let's see where that capacitor is going. It's a filtering cap, so we can either ignore it or we can probably solder it just to keep them capacitor gang happy. Right there, that's enough. Now we're just gonna get it straight. Let's get it straight, or the people in the comment section are gonna be mad. There we go. So that takes care of that. Now what's going on in here? Let's go and plug in the cord back into the power supply, because I want to see how things change. If we start poking around, my bet is we're missing 5 volt somewhere. Probably one of them pull-up resistors eaten away or something, I don't know. Okay, so we are here. So luckily this is the kind of card that we have all the diagrams and schematics for, so we're good. I just want to make sure that we're not shorting anything out. Man, this looks really bad. So there's a ground somewhere here. Okay. What is this? So nothing. Yeah, I do not know the value of this resistor, but that resistor is definitely eaten, as well as this one. So I think we have a problem with, oh, we got an eaten pad here too. Do we even have 5 volt on? Well, we should. Okay, so let's go ahead and I'm just gonna remove these 2 resistors. I think the legs on these things are still there, and matter of fact, we can probably go ahead and poke around the. I'm gonna insert the HDMI cable. Where's the HDMI cable? Yeah, I'm gonna insert the cable, and so if we see screen flicker when we power it on, then we know something worked. So right now, nothing happens when I flip the switch. So, but we're gonna replace these 2 resistors. Actually, let me go ahead and check for voltages. See what we got. What do we have here? 5. What do we have here? 3.2, 0.5, and 0.5. 1 volt. Not even 1 volt. 0.5 here. So very strange. Whatever. I don't know exactly what we're supposed to be getting in here, but I don't care. Let's go and replace these 2 resistors, whatever they are. Take them out first, obviously. Yeah, one is definitely cooked, and the other one doesn't want to come out. Probably a pull down resistor or something. Oh, there it is. Okay, now let's have a look at what we've got. We want to see the condition of the board underneath those resistors so that we can evaluate what needs to be done. Looks like, let's zoom in a little bit closer. Adjust the lighting maybe. There we go. So if we were to solder a resistor here, nothing would happen because it would not be connected to this pad. So we're gonna need to, we can probably run a wire. Oh, there's a via there too. See this via? I really hope that via is good. I really hope so. Because just like in the case with that 3090, the rusted via had given us a lot of trouble. So let's go ahead and populate this with some kind of a pad that we can use to solder the resistor to. Do we want to go this way or do we want to go this way? Now, where is that pad? I want it right here. Okay, let's apply some solder on the trace. There we go. I'm gonna put that pad there. And there we have it. Great job, everybody. Thanks for watching. Have a blessed day. Alright, so let's get this trimmed. And now we need to figure out what is this. This here looks like it could be an issue. See this? The trace. Is the trace completely gone? Oh, it doesn't go anywhere. I thought it was going to go into this resistor here. That would be a huge problem. But it does not. I don't think so. So let's just going to look around this general area to see. Yeah, this pad's eaten away, but it doesn't seem to go anywhere. Or this one. So I think we're good. I think all we need to do is to bring in the resistor here and here and see what it does. Kind of makes me wonder. No, none of them are pulled down. Okay, who cares? Alright, let's switch to the board view. Here's the board view, and here is the circuit. Okay, so we have... Oh, it's 12 volt, yeah. It's a DP auxiliary whatever this means, 12 volt. So that explains why it was a little bit difficult to remove this resistor because it's connected to the 12 volt. So 10K, 10K, easy enough. Let's do 10Ks. 10K is probably one of the most common resistor that's used. So be sure to stack up. I have a lot of these in that little book where I have all of my resistors and capacitors. When I use them, I end up writing the ones that I use the most, and then so that way I don't have to order what I do not need. So I bought this book once. It's already falling apart because it's made in China, obviously, but at the very least I know exactly which components I use most of the time, so that way when it comes time to order more, I will not have to waste, you know, $30, $70 or whatever it costs for the whole book just to use 1 or 5% of it. I would end up buying only what I need. Alright, let's solder these guys down here. Probably start here. Oh no, I hate when that happens. Okay, I need to rotate the board. I can't work in these conditions. There we go. There we go. That's one. And the other. Okay, so that looks good enough. I'm gonna go ahead work that transistor, whatever this thing is, just to resolder some of its pins. Make sure that they're good. Probably need a little bit of heat. Yeah, that looks good. That looks good enough for me. Alright. Let's zoom out. Give it a gentle wipe with the Q-tip. Plug the PCI Express end of the tester, and let's see if just by flickering the power switch, the display or the HDMI port that I have connected here will react instantly. Here goes nothing. Nope, still nothing. There's nothing here. Okay, so there's probably still something else that we do not know. I wonder if that thing here actually broken, or we may actually have a bad via like we suspected before. Yeah, I don't see anything that's not working. Alright, who cares? How does this supposed to work? I do not know. Let's see what kind of voltages are we getting now that we've resoldered those resistors. And also I want to see whether or not we actually do get 12 volt on those resistors. Okay, so first order of business, let's see. We still have 5 volt. Oh, see this? The leg is missing. Yeah, so I can try to add more solder to this and see if that helps. But the leg on here is completely gone. See, I can probably, I'm gonna put in some black horse in here. I don't know, like, there's nothing to solder to because the leg is complete. Oh, looks like I did that. That did it. You think that did it? It's a little blob just sort of hanging on that, on whatever left of that leg on that transistor or whatever this thing is. Let's flip the switch, see if the HDMI port will react. There we go. Nice. So the HDMI port is now reacting to the switch, which means I think we fixed it. Let's go ahead and plug this thing into the motherboard. See if it'll actually post. I think it should. Alright, here goes nothing. Instant reaction to the HDMI port. Very good. Let's see if we're gonna get an image on the screen. And we do. Just a second, it's gonna show up. There we go. Perfect. So we fixed it. The only problem I have with this repair is that I don't know if it's going to last. Because soldering... Well, let me show you what I mean. We soldered that blob. What's going on with my power here? There we go. So we had that blob soldered to the very edge of that leg that's barely even there. I mean, it's there. Now that I look at it, yeah, it's actually not too bad. That got me worried a little bit. I thought it was like completely gone, but it has enough stick out that I wouldn't worry about it. But I will do some preventative maintenance for this and get it all sealed up to make sure that it does not break away anytime soon. Okay, so that looks okay-ish. Maybe I should probably replace it. Let me go see if I can find a donor board where I can steal that from. And I did. I got a exact donor board here. That's good. So we can steal whatever this thing is from here, put it there. And that's gonna be way better than just have it soldered there halfway, dangling to its last, on its last legs. There we go. Having a donor is always nice. I'm gonna need to solder that back down in there somehow. There we go. We need to fix that blob. There we go. That looks good. Need to get it cleaned as before and apply a little bit of mask so that everyone's happy. Alright, the mask is gonna go over that trace repair right there. And that should be it. Let's get that cured. Easy pizza today. Definitely, I am definitely happy to give the customer good news that this was an easy fix, because he was a bit upset with the last repair. Donor board was not cheap because it's hard to find a donor board for a 3090. You can find... My supplier can't find a good board for 3090. He finds me things that are like in a terrible, terrible condition. Maybe I should find a different supplier. I don't know. Who cares? But I was lucky enough to have like new condition sitting here on the shelf. Regardless, gonna put this thing back together. I'll run some tests. Give the customer good news. Also makes me wonder, what is the purpose of this thing here if it does not cool absolutely nothing? Look at this. It's not cooling. There's like no driver MOSFET anywhere, nothing. It's just sitting there acting like it's busy. Just like that guy that I used to work with. He just gonna sit there acting like he's busy, and then he died. Poor bastard. And I'm still here. Ooh, look at that. That's where all that come from. All that sign. I thought it was like some kind of heat or something, but it turned out to be all of that damage there. So I guess customer has a leak problem and should look into that. So either way, I'm done mumbling here. Hopefully this was educating. Let me know what you think about this repair in the comment section below. Okay, since our last repair was too easy, I figured we probably can continue this video with the next one. This is the EVGA 2080 Ti. Probably the one of the best 2080 Ti's that you can buy. But it's dead. So even though it's EVGA, it's dead. And the customer's lucky here because we have Samsung memory instead of early Micron. So at the very least, we don't have to worry about the memory. But something is wrong. It does not post. I don't know if it's even detected. The motherboard is instantly complaining about it. Refuses to boot, which is never a good thing. Oh, these wires just keep breaking off. I don't know if I'm going to be able to power this thing with so many wires breaking off. I probably should either fix this connector or replace it. I do have a couple of replacements, but I also bought a bunch of pins, which are very expensive, by the way, in order to fix this connector. So let's go and see if we even have power everywhere that we want to have. Because it's pulling like 1.5 amp or something with 3 fans. Yeah, we got 3 fans here. Yeah, so that's too little power. I mean, 1.1 amp or something. It was very sketchy. So something is definitely wrong with this card. I do not know what it is. Hopefully it's not. Hopefully it's not a dead core. Most of the time when a 2080 comes in, 2080 Ti or something. It's usually artifacts or something or crashes along those lines, but almost never no detect or no power. So when I get things like that, I'm a bit skeptical. Okay, so that looks kind of okay. Let me turn that off. I want to turn it on one more time. Oh, that looks good. The only thing that I do not see are the two coils that are on the top here. These two coils. Oh, we're pulling 2 amps. If I'm not mistaken, let me turn on the meter. Hey meter, where are you? There you are. There. Memory. See, memory here, memory here, memory here. But when we power this thing on, we get nothing. So that kind of explains everything. It's doing 2 amps all of a sudden. It wasn't doing that before. But we have no memory. And the card had never been opened before. Why does it not have memory? Who drives memory? No idea. I think we're going to be driving the memory from this corner over here. Let's have a look. Maybe we can look at that driver MOS, that PWM controller through a camera, thermal camera rather. See what's going on. So you can see a little bit of light on these driver MOSFETs. But turn that off. So there's a little bit of light, so they definitely get turned on. And that's it. Basically, they just get turned on, and that's it. All right, that's just incredible. So the worst part about the EVGA is that there'll be no schematics anywhere. There's gonna be no board views, nothing. So what is this? It's a UP9512P. I don't think this is what's driving the memory. This is probably driving core. So we're gonna be looking for something smaller. Let me get that light out. Something that's not gonna drive, because this here is able to drive 8 phases, and we only have 3 for the memory. So this one's most likely driving everything else but memory. Let's scroll down here. Another power monitoring chip. What about the back? Do we have anything on the back? We got, ooh, another PWM controller. Huh, interesting. Let me go situate the board. It's a little bit sitting a bit too high off the ground, or too low rather, something like this. Very interesting. I have no memory, so all right. Let's look around. I'm not exactly sure which of the two will be driving the memory, but we can figure this out. So let's go into, we need a pin number 36, which is gonna be, all right. So how many pins do we have? I got 1 2 3 4 5 6 7 8 9 10. So that's 20 31 30 33 4 35. Wait, 1 2 3 4 5 6. That's going to be this pin here. If I'm not mistaken, this is the enable signal. Let's see if we're getting any kind of voltage on this pin. So we got a 2.4 volt on the enable, which means this controller is the one that's driving the core, not the memory, but the one on the at the front. It's gonna be 1 2 3 4 5 6. This one should probably have 0 volt. No, it has all the volt, and the board is now doing 0.4 amps instead of 2 amps that it did just a second ago. Very interesting. Why does it do that? So both of the PWM controllers are definitely running. They're definitely doing their thing, or they have an enable signal. But we, for some reasons, have no memory. And as you can see here, the board is pulling 1.4, 1.2, whatever. Oh, it just jumped to 2. Do we have memory now? No, we still don't have memory. Why is it doing that? Something's definitely sketchy here, because it seems to behave differently when we power it each time. Don't know why that is. It's gonna be another one of them rust or something. I guess I can look around, see if I can spot any kind of rust. But this is definitely looking very interesting, because it seems to be pulling still 1.7. Something's definitely changing it when we cycle the power. I wonder if, oh, did you see that? The 2.5 amp or something? Let's see if I can play around with the hook area here. 1.7. Oh, it went into 2 amp. Nope, that doesn't do it. So that doesn't seem to change a whole lot in here, but something's definitely does. Let's see if maybe pressing on the CPU changes anything. I'm gonna press down here. Nope. What about here? Kind of. Well, that kind of changed. it changed quicker. What about here? No, not instantly. I want to see instant change. I want to see 2 amps instantly on here, but I don't. It kind of tries, but not really. It stays low and then it kicks up a notch. So not sure. Not sure. Anyway, I'm gonna look around and see what I can find. I don't think we have a cracked a cracked board here, do we? Let's have a look. Otherwise, I'm gonna have to look around, see if I can find anything suspicious. It looks fine in here, and on the other side, and the other side is looking fine as well. Right there. Yeah, there's nothing. And the board was sealed, so it was never opened. So looking for knocked off components is kind of a waste of time. But we're gonna have to look for something else, probably for a bad signal. So my suspect number one is obviously that memory PWM controller on at the front of the board. This guy here. So I want to check. I want to check if it's shutting down because one of the driver MOSFETs on memory is faulty. So that could happen. It would basically shut itself down too quick for it to do any kind of damage, or for us to even be able to detect anything. So let's go and check this controller here for some contacts. All right, let's switch over to a desktop. So what I'm doing right now is I'm trying to cycle through whatever board view I can find that uses same controller to drive the memory. So what about this one here? Where's the PVM? PVM in, goes through the back into, wait, what? FBVDQ. Wait, what? This one's driving memory? No, we don't even have that on the board. This board does not have that. So wait a minute. What drives memory on this thing? I am so confused. So it could be this one, but it could also be a smaller one. Okay, so let's go with this one. Let's go PVM1. See where that goes. Where does that go? No, 40K 0 ohm. So that's gonna be through the back, and then that's gonna jump over to the component right there. Okay. So if we get this pin connected to the third driver MOSFET here, then that's the controller that we're looking for, which I think is the case. So let's go and try to look this up. Okay, so here's the controller. Pin number 1 is going to go into this resistor here, and we're expecting it to land somewhere here. There. All right, so we got that. Okay, so that's the one that's driving the memory. Okay. Do we have like a VCC on this thing or something? Let's see. PSI enable, seal, SDA, OP4. I think OP4 is going to be this pin here, 33. It's either this, it's one of the OP pins, the VCC. Where's the VCC on this thing? All right, that's what we got, right? Right, 9512P, yes. So, where is, yeah, that was a temp sense, who cares? We're looking for a 5 volt, so 5 volt main pin number 12. So, okay, easy enough. Minimize that. So pin 12 on that guy. It's going to be pin 12. Yeah, OP10. Okay, never mind. That's that big boy. Do we have 5 volt? We should, because we have enable. But do we have power good? Power good's going to be third pin down from the top right. Power good's going to be 1, 2, 3. It's going to be here. No power good. Power good is shorting out. Okay, so the power good is generated by the PWM controller only if everything is powered. So why does it not give us the power good? And it's not giving us the power good because none of these phases are working. So PWM 1, 2, 3. Let's measure the voltages on these 3 phases. So we got 1, 2, and 3. So 1's gonna be here. 1.1, 5, 1.4. Wait, where did that go? Oh, our layout here is terrible. We probably can measure it differently. 5. That's gonna be the same thing. 1.7. I don't know which one of these PWM pins connect to the driver MOSFETs, but I'm guessing if we're reading here, which is PWM2, then which driver MOSFET would that be? So if this one is 1, if this one was 1 for the memory, that's gonna be 2. So it's gonna be here. Let's click here, PWM, click here. Okay, so yeah, on this one we are reading a very different reading compared to these two. Compare the two that are up here and up here in the middle, we're reading a very different value for some reasons. So that means that this driver MOSFET could potentially be faulty. I don't know. I just want to disable the temperature monitoring circuit so that I can force power this on and see if this driver MOSFET is going to start glowing. We can disable temperature monitoring thingy just by removing this 0 ohm resistor. See if we have one there. Is that one? Two, yeah, that's the one. So it's going to be this resistor here, I think. Is it 0 ohm? Yes, this one. And that will basically disconnect that from monitoring this chip for overheating or any kind of faults that it may have. Let's see if removing that somehow fixes the problem, or exposes it rather. Alright, so there's that. Let's see if we have memory now. Nope, nothing changed. Yeah, the only thing that I think that's wrong here is I do not know. So let's solder that thing back on where it was. I still think we have a half-dead driver MOSFET, and that we're simply unable to force power that thing in order to see what's going on. So how do we do this? Okay, so if we have, we just need to find, a one of the U-gates that does not have a power good. Let's see if this one has. This one's got it. What about this one? This one has it. What else? This one here. Check. Here. Good. Any more U-gates? 2 in here. Check. Check. So the U-gates are fine. I'm just looking for whatever U-gate. Just give me some kind of U-gate that does not have a output. What about this one here? Looks like all of them work. Alright, so I can't really seem to find anything right now. I'm gonna go look around. And let me fix the focus here. There we go. I'm gonna go ahead and look around, see if I can find something out, and then I'll let you know what I find. So this is like the only U-gate here that I cannot have output for the no power good output. That's PCI Express detection most likely. Other than that, no idea. No idea why it does not have memory. So, oh, there's D1. Okay, so I'm gonna go ahead and try remove D1 really quick. See if it helps, because a lot of times these D1s help to force certain things to work, even when there's something failed. It could potentially expose faulty driver MOSFET. So I want to get this diode out of there. Usually it works for the core voltage, not for memory. So I don't know if it's going to help or not. Okay, let's see what happens when we flip the switch. We'll probably check for memory here. Nothing. So that didn't help. I'm going to put that thing back on and start looking around, I guess. I want to go back to the memory phase controller for whatever reason. And I want to see if... I'm starting to think that the controller is probably bad. Let's go and check. I want to see if I have any kind of pulses coming. Even the brief pulse coming off of the controller on any of these phases here. So this is going to be phase 1. There's definitely a pulse. There's definitely a pulse here. And a pulse here. So I'm getting a pulse, but... And we have other stuff. Do we have PSI? Because some of these voltages you're not even going to be able to see until the whole thing is actually running. So we should have, I believe, PSI somewhere here. Yeah, 1.8. So we're good there. Enable. We have the enable is getting pulled low. Isn't that correct? So 1, 2, 3, 4, 5 from the bottom. Yes. So 1, 2, 3, 4, 5. This one. Yeah, we have the enable. So the controller is enabled. We got the PSI. We have no power good, obviously. We can check the last 2 pins. So nothing here. Sketchy. And then this one here, 0.9. Yeah, that's the PWM in coming from the core, so 0.9 volt is perfectly fine. The ref adjust, we have nothing on the ref adjust because nothing's in the output, right? Yeah, there's nothing on, it's like 0.7 volt, whatever. Yeah, there's nothing here. Ref in, we can check, and the VREF. So the ref in is going to be pin number 1. Let's see. One of them is supposed to be 2 volt, 1.4. So that's reference in. That's the voltage that we're trying to set. And the voltage reference, 2 volt. So everything's fine. I there's no reason for this controller not to work, but it doesn't work. So screw this. Let's replace it. I got a ton of these controllers sitting around here, so replacing one won't hurt anybody's feelings. So let's do that real quick. Well, let's see if this guy's gonna come off anytime now. Come on. It's got a giant ground pad underneath it, so it's a little bit difficult to remove. There we go. There we go. That was painful. Okay, let's see if I can prep the pads just a little bit. Okay, the pads look good. Here goes the other chip. Not new, so who knows, it might not be working either. There we go. That looks okay-ish. Make sure that we iron the edges. Whoopsie doozy. Okay, let's back out with the hot air just a little bit. Let it settle down and iron the edges. There we go. That looks beautiful. Okay, clean up, cool down, and hopefully this is it. Because other than that, I am out of ideas what could possibly go wrong. Except that I'm struggling to figure out how to force this power stage to turn on so that we could see which of the driver MOSFETs is causing the shutdown, if one of the driver MOSFETs is actually does cause a shutdown. I just never know. This is not an MPS controller that I could solder a couple of wires to and go read the status and see the error message relate to whatever phase or whatever. This is like the good old made out of wood and stone controller. One of them dumb controllers that just happens to not talk back a whole lot without a special type of equipment to connect to, which I happen to have, but never came across, never came around to actually connecting to it and actually testing it, because a lot of times you just replace this thing and it fixes the problem. So sitting here wondering about which phase is bad or whatever, over time just kind of proved a point that investing money into dongles or readers for these UP controllers is a waste of time. Alright, so let's cool this thing down a little bit. In case one of the driver MOSFETs actually starts to glow, and then we'll be able to see it. Alright, here goes nothing. Look at that. I think we have memory. Check it out. There. We got memory. I'm going to show you what I got. I do have it though. Just never came about actually using it. Like not once. For whatever reason. It's called Elmore Labs. Yes. Elmore Labs. So it's a thing that looks like this. And it's I have no idea how to use it. But I bought it anyway. Out of curiosity. Just wanted to see. I don't know if anybody knows how to connect this to this. Please let us know. But I don't care either way. I have no intentions of using that thing ever, given how easy it is to actually repair these things without ever even bothering to solder anything onto it other than a different chip, you know. So who cares? All right, here goes nothing. Let's see if this thing will actually work. Oh, one happy beep. I think it's posting. Perfect. I think we fixed another GPU. Okay, so the thing died again. Not exactly sure why. Maybe because I was tinkering with the power settings while the GPU-Z and other sensor monitoring software were open. No idea, but the symptom is exactly the same. We lost memory voltage. Don't know why. Maybe bad controller. I'm gonna try swap it again, and we're gonna check for signals. Make sure that, though I do not remember if we checked them again before or not. I don't think so. But we're gonna check them this time. I got plenty of these things sitting around here, so replacing another one is not a problem. The problem is finding out why it fails. Hopefully replacing this one more time will make it work, but who knows? Or maybe it was a software lockup that caused this thing to fail. After all, it's the EVGA, just too many things. Too many things that can go wrong here. Their software is poking its tentacles into places where it shouldn't really. But I don't know. Okay, that looks good. Clean it up as before and try it on. Hopefully this time it's permanent, because we did use used controller, so it may have been partially dead, couldn't handle the load, I don't know. But we're going to be checking these phases just to make sure that everything is actually working as it should be before we put it back together. I'm guessing just by swapping the controller without doing any kind of additional diagnostics, we might end up having memory on voltage right away. As a matter of fact, we can check. Still a little bit hot, but we can check. There's no voltage on the memory. Why is that? Is the memory short? It's not. Well, we got no voltage. Why is that? Do we have VCC? Yes. What about what's in here? Nothing. Still got this. Still have reference in. Something. What is it that we needed to check? Pin 36, enable. We have enable. And we have this, PSI. But no memory. So, why? Why do we have no memory? Could it be bad controller? Possibly. So, let's replace it again. Except this time we're gonna use a brand new one. Maybe that's all it is. Maybe all these used controllers are junk. Who knows? Probably worth a try anyway. Or maybe something else is going on with the board that I do not understand. Maybe it fails after it gets heat up. That kind of explains it a little bit, because when I tried to power this on while it was still hot, just a minute ago, there was no power. And that it did run briefly before it actually warmed up. So that the heat could possibly be a tell of what's going on in here. I don't know. I have to put a little bit of solder there. There we go. So the controller might actually be okay, but I'm gonna double check using a brand new one. Okay, there we go. Yeah. Alright, who knows what's going on in here. Problems like that manifest themselves when things get heated is one thing. Usually if the voltages are still there and you get like crashes and whatnot after it gets warmed up, so that's likely a cold solder joint under the core or a memory chip maybe. But in this case the problem is completely different. We're totally losing voltage on memory while the board is warm. We just need to isolate. I suppose one of the tricks that we can do is we need to isolate the part of the board that has to be hot in order for the voltage to fail. And then, because we've seen that from the very beginning, the alternating consumption, it would jump from 1.5 amp to 2.2 random, but the memory voltage would still not be there. And for whatever reason, after replacing the controller, the voltage came back, but it did not last for very long. So let's see if we have voltage now. Still no voltage. So it's definitely not a controller issue. The issue is somewhere else. Where's the issue? I don't know. All I know now is that if we leave this cool down, it'll probably work. We just need to see if I can cool down the driver MOSFETs, especially the second one here. See if that works. That'd be interesting to see if just cooling it down makes it work. It'll blow it all out. Okay, let's see if cooling down driver... Oh, there you go. See, that works. Now the issue is we need to figure out why does it work. Which of the two driver MOSFETs, or the three, is the one that's causing the trouble? No idea. So what we can do is I'm going to apply a little bit of heat. I'm going to apply a little bit of heat on the top one here. And we're going to be monitoring. Not exactly sure what is it that we're monitoring here. I'm going to put a cooler on the core because I need to keep it on while I'm torturing it. Okay, so there's our cooler. So when this thing is on, I am monitoring the voltage on the memory, and we're going to start heating up the driver MOSFET in the middle. Right there. It's gone. It instantly went off. See right there. No more voltage on memory. So I think it's the second one. We can try to disconnect that resistor there from before. Remember the TMON. See if that changes anything. Just move it out of the way. All right. So does that bring the voltage back to the memory? It does not. Okay. Let's disconnect the other two. I swear one of these driver MOSFETs is probably the one that's causing all these issues. That, and then that goes here. Let's see if we have voltage in memory now. Still no voltage. Then it's not the driver MOSFETs, it's something else. Or at the very least, it's not this circuit. It could still be though. Still no power. Okay, let's cool down the one on the top. See if that helps. Still nothing. Let's cool down the second one down. There you go. So we got memory. So it looks like this is the guy. But why? Could it be this one? Let's see if it could be the second driver MOSFET. So I'm gonna do is I'm going to try to heat up the third one. Nope, 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 nope. Still there. Still got voltage. Very interesting. Well, we still have voltage, so I don't know. Looks like heating it up. Looks like heating it up didn't change a whole lot. This time, at least. Don't know why that is. Seems to work. So maybe we already fixed it, or maybe we can just reflow these pins. Hold on, a UPS came in. All right, let's reflow some of these resistors here. Who knows? Maybe they're the ones that are causing issues. I don't know. I can't seem to point to anything really, to anything specific. Maybe there's something on the back. Let's do some stuff on the back as well. I see a little bit of silicone related stuff in here. Who knows? Could be something, could be nothing. Sometimes silicone doesn't really rust anything away, but it kind of creates problems like that, intermittent connections and whatnot. So it could be where the problem's originating. It's hard to say. Can't really think of anything else right now. Something is like not soldered properly or whatever. Bad solder joint somewhere. Something's becoming loose that temporarily connects when the board is cold and keeps disconnecting when the board warms up. So all I need to do right now is to make sure that it'll work both times when the board is hot and the board is cold. Since we seem to have been successfully able to rule out the controller itself. So right now the board is kind of hot. Let's see if it'll give us the memory voltage. No voltage. So there, whatever we just did helped us nothing at all. So still have everything. Yes, we still have everything except for the memory. So something is definitely still causing this issue, and I don't even know what it is. I'm starting to think it's got to be one of the driver MOSFETs, but I don't know. Nothing here. Nothing here. Let me see what happens when we touch the TMON pin, and then we touch this. Nothing. Okay, so let's wait for this thing to cool down a little bit. Still nothing. Cooled it down, blew it out. Still no power. Why is that? No idea. So for some reasons, after reflowing a number of components, we have no voltage on memory at all. And do we have... what is the resistance on memory now? Still normal. Okay, so the resistance on memory is normal. And there's still nothing on that memory. Have no voltage on memory whatsoever. And all we did was we reflow a couple of things here. We resoldered some of the pins for the driver MOSFETs, few resistors, and now it's not working at all. Very interesting. What is this? 5 volt coming in and out. 12 volt. Okay, so this one's good. 12 volt here. Yep. Why does it not work? No idea. Did I just feel something hot to my finger? Look at that. Look at that. Did you see this? What's going on in here? Whoa. See this? It's this U-gate. What's wrong with this U-gate? Why was it burning my finger? What's shorted? Shorted output. So the output of this U-gate is now shorted. Uh-huh. Interesting. Why is it shorted? Okay. That's new. Let's see what's shorted here. So 1 volt coming in. I don't see anything. Like nothing whatsoever. Yeah. Oh, there we go. There we go. Look at you. Look at you, you little bastard. Where are you? I swear you were right there. It doesn't want to work anymore. Why not? Why is it so difficult to detect? Okay, let's do a little bit more volt. Oh, there we go. There we go. This one is this guy. So this bad driver MOSFET. Jeez. Took a while to find it. Hopefully this is it. Let's see if we can, yeah, one of them half-dead driver MOSFETs. Definitely will take a while for you to find one. So just need to identify, replace and destroy. No easy pizza with this one today. But at the very least we have some content to chew on for some of you out there. Always a good thing. Alright, so and then we're also going to have to resolder all of those T-mon resistors. And this one is FMDF 3170. Let's go and find one. Okay, let's see things. Good here. The U-gate is no longer shorted, so that's good. I think we're okay. Let's see if we have memory voltage. Yes. Okay, so that's good. Instant memory voltage. I'm gonna go and check. I think I already have in the past. I don't remember. Phases here really quick. Make sure everything's looking good. Good, good, and good. So these look really good. Let's do a torture test. We're gonna watch for voltage, and we're gonna heat this thing up. Make sure that we're not getting any kind of voltage loss. Nothing. Everything's looking good. All right. So back to square one with the test. Put it back together. Hopefully this time this is it, because I am tired already. Even though it's 9 o'clock, I'm gonna finish up with the testing on this one, and we'll probably start the next one anyway, because I got nothing better to do. No wife, no life, no kids, nothing. Repairs is all I do all day long. I don't go anywhere unless absolutely necessary, like a UPS store to get the packages, and that's it. That's basically my life here, if anybody wanted to know. It's kind of how it was for years. So, and I'm not complaining. It works out. So I'm gonna have, obviously I want to clean that up. So I'm gonna go clean this up, and hopefully this time the test will go through all the way without any hiccups. And as for you, thank you for sticking around for that long. Goodbye.